Assalamu alaikum. Good morning, students. How are you? Hope you all are fine. Welcome back to my class. Today I am here to take class for standard 11 and 12. I will explain from chapter 3, that is current electricity, and this is my 8th number of lecture. Today's topics: application of a shunt in a galvanometer. Today, I will explain you application of shunt in a galvanometer. So we have to understand at first what is galvanometer. The galvanometer is the device used for detecting the presence of a small current. The galvanometer is mainly used in the gauges and potentiometer, where they indicate the null deflection or zero current. What is called shunt? In electronics, a shunt is a device that creates a low resistance path for electric current to allow it to pass around another point in the circuit. The origin of the term is in the verb to shunt, meaning to turn away or follow a different path. In all electrical instruments, there is an upper limit of flow of current. If current flows above the upper limit, then the instrument may be damaged. In the laboratory, we use some instruments which are very sensitive. Through these instruments, if more current flows, then they might be damaged or become inactive. These instruments are, for example, galvanometer, voltmeter, etc. These instruments are used for measurement of flow in the circuit. In order to save all these instruments, shunts are used. So let's observe how shunts are used. Look here, this is galvanometer and shunt. This is the shunt which is connected in parallel connection to the galvanometer. The resistance of shunt is taken very low so that most of the portion of the current can pass through it, and as a result the galvanometer can be saved from being damaged. Because you know, galvanometer can show the deflection when there is existence of current, and it can measure very few milliampere of current. So if current passes through it, most of the current passes through it, then it can be damaged. So in order to save the galvanometer or ammeter, a shunt is connected in parallel connection. Now I will discuss the application of a shunt in a galvanometer. Suppose a resistance S of small value is connected between the two ends A and B. Look here, A and B, the two ends of the galvanometer, parallel to the galvanometer of resistance capital G. Here the galvanometer and whose resistance is capital G. This S is the shunt. Let the principal current I reaching at point A be divided into two parts. Okay. One will go through the galvanometer and another one will go through the shunt. A small portion of the principal current will flow through the galvanometer and large current will flow through the shunt, as the shunt's resistance is taken very low. So most of the current will pass through the shunt. As a result, the galvanometer will not be damaged due to heat produced. Look, dear students, the potential difference, now we will measure the potential difference between the point A and B, that is across the galvanometer, and we will measure this potential difference according to Ohm's law. So according to Ohm's law, you know V equal to IR. Potential difference V equal to IR. So here, if V is the potential difference between point A and B, then we get V equal to Ig into capital G, because here the principal current I is divided into two parts, that is Ig which goes through the galvanometer and Is that goes through the shunt. and the resistance of the galvanometer is taken as capital G. So we can write V equal to Ig into capital G, equation 1. And the potential difference at this 2 point will be what? That means across this shunt. So V equal to ISS according to Ohm's law. That is V equal to IR. Here S is the resistance of the shunt and IS is the current that passes through the shunt. So V equal to IS into capital S. Dear students, you know very well when two resistors are connected in parallel connection, then the potential difference at the 2 point across them is same, but current will be different. So here we are also looking that the current to the galvanometer and current to the shunt is different, but as they are connected in parallel connection, so the potential difference at this 2 point and also at this 2 point becoming same. So we can write what? These two potential difference is same. So we can write Ig into G equal to Is into S. Okay. From this, we can also write Is by Ig equal to G by S. This is equation number 3. So equation number 3, you remember maybe, that is Is by Ig equal to G by S, and we will add 1 on both sides of that equation. Then what we will get? We will get 1 plus Is by Ig equal to 1 plus G by S. Then by simple algebraic calculation we get this, that is Ig plus Is by Ig equal to S plus G by S. Dear students, look here, the principal current reaching at I divided into two parts, Ig and Is. So here we can apply Kirchhoff's current law. A is the junction, and you know at any junction the incoming current equal to outgoing current. So we can write I equal to Ig plus Is. Okay. So in place of this Ig plus Is, we can write only I. So I by Ig equal to S plus G by S. Now we will find out the current that passes through the galvanometer, and the current that passes through the galvanometer is what? Ig. So we can write Ig equal to S into I divided by S plus G. Look, it is very simple. Just we will do the cross multiplication. Okay. So we got the equation Ig equal to S into I divided by S plus G. From this equation, we can also find out the value of principal current I, that is I equal to S plus G by S into Ig. Now we have to find out the value of Is. So here in the previous equation we got S plus G by S. This has a name that is called power multiplier of the shunt. The multiplier by which current of the galvanometer is multiplied to get the main current is called the power multiplier or multiplying power of shunt. So again, putting the value of Ig in equation 3. Equation 3, I think you remember, Is by Ig equal to G by S. Equation 3. So from here, we can write Is equal to Ig, just cross multiplication, Ig into G by S. Here we will put the value of Ig that we found out in the previous slide. Look, Is equal to Ig into G by S. Now we will put the value of Ig, because you know Ig equal to S into I divided by S plus G. So let's put the value here. Ig equal to S into I divided by S plus G into G by S. By calculation it comes G into I by S plus G. So we got two equations, that is for Ig and for Is. That is the current that passes through the galvanometer Ig and the current that passes through the shunt Is. Dear students, these two equations you have to be remembered. You have to be memorized. Okay. So this memorization is not that much hard, very easy. You have to apply a shortcut technique. If here G, then here will be S into I, and the denominator in both cases will be S plus G. Here IS, so here will be G into I. Okay, in that way you can remember. That means IG, if IG, then it will be S into I by G plus S. And if IS, then it will be G into I by G plus S or S plus G. Do you understand this calculation? Now, I will explain you how can we increase the range of an ammeter. An ammeter is basically a permanent magnet moving coil instrument which deflects for a very small amount of current in milliampere range. It's only possible to increase the range of an ammeter, but we cannot decrease the range of an ammeter. The range of an ammeter can be easily increased by adding a shunt resistance of very low value to bypass the major part of the current through the resistance path instead of ammeter. This increases the range of an ammeter by reducing the actual current flow through the ammeter. Dear students, I have explained this because in creative questions sometimes this type of problem is given. That is, how can you increase the range of the ammeter? So you have to explain mathematically depending on this theory. Now I will show you a mathematical problem. But before doing the math, I want to explain you another one thing. I want to ask you one question. What will be the current flowing through the galvanometer if the resistance of the shunt is 0 or infinity? If the resistance of the shunt is connected in parallel connection with the galvanometer. So if the resistance of the shunt is 0, then what will happen? No current will flow through the galvanometer, rather all current will flow through the shunt. Okay, because you know current always choose that path where there is less resistance. Okay, and if the resistance of the shunt is taken as infinity, then what will happen? Then total current will flow through the galvanometer and the galvanometer will be damaged. Now let's do the math. At first, read the stem. While doing experiment in the laboratory with a galvanometer of 100 ohm resistance and range of 10 milliampere, Harun connected the circuit as shown above. Just at that time, the teacher asked him to transfer the galvanometer into an ammeter of 10 ampere range, and he made some change in the arrangement of the galvanometer. Now the questions are: A number question, calculate the value of S of the given circuit. B number, explain the change that Harun brought in the galvanometer circuit according to the instruction of the teacher. Solution. At first we have to find out the resistance, that means resistance of the shunt of the given circuit. We know current in the galvanometer, the formula is what? Ig equal to S into I divided by S plus G. By using this formula, we can find out the value of S. Okay. So look here, what is given? Here Ig equal to 10 milliampere. It is given in the stem that the galvanometer can measure 10 milliampere current. Okay, the range of the galvanometer was 10 milliampere. It can measure only 10 milliampere current. So Ig equal to 10 milliampere. Okay, so we can write this is 10 into 10 to the power 3 ampere, because 1000 milliampere equal to 1 ampere. Okay, so in order to convert it into ampere, we have to multiply it with 10 to the power minus 3. So it becomes 10 square ampere. Now we will put the value. So here Ig equal to S into I divided by S plus G. By cross multiplication we get Ig into S plus G equal to S into I. Now put the value. Ig equal to, we got it, 10 square into S plus G, S into 1, because here I is the principal current and the value of principal current I equal to 1 ampere. So S into 1 equal to S. Now we will transfer this 10 square into that side, so then that time it will be 10 inverse 2 will be 10 square, that is 100. So S plus G equal to 100 into S. When we transfer this 10 inverse 2, it will be 100 in that side. But now by simple calculations, we get the value of S equal to 100 by 99, that is 1.01 ohm. Very easy math. You have to practice this type of math. There are many maths are given in your book, that is the book written by Dr. Shahjahan Tapon or Amir Hussain. Any of the book you can choose, or you can also do both of the books. The more you practice, the more you learn. B number question was what? Explain the change that Harun brought in the galvanometer circuit according to the instruction of the teacher. So he can change the shunt. How can Harun brought the change? He can change the shunt. If he uses shunt S prime in place of S, then we know the equation of galvanometer current is what? Ig equal to S into I divided by S plus G. So here we just replace S. We will put here S prime, because by changing the shunt, he can bring a change in the galvanometer. So, and here the principal current I equal to 10 ampere, because in order to change the galvanometer, which can measure 10 ampere current, that means in that case the principal current will be 10 ampere. So we are bringing the change of shunt, and here we put the value. Ig will remain same, that is 10 square, because the range of the galvanometer was 10 milliampere. Okay, and 10 milliampere means 10 square ampere, that we got in the previous slide. So 10 square, that means we Ig into S prime into I equal to, Ig into S prime plus G equal to S prime into I. So in that equation, we put the value of Ig, that is 10 square, into S prime plus G equal to S prime into S. Here I equal to S prime into I, and here I equal to 10 ampere. Okay. Now by calculation we get S prime plus G equal to, this 10 square will be 10 inverse minus 2 will be transferred to that side, so it will be 10 square in that side. So S prime, the value of G is what? Galvanometer resistance 100 ohm. S prime plus 100 equal to 1000 S prime. So 999 S prime equal to 100. So S prime equal to 0.1 ohm. That means the resistance of the shunt is taken very low before the previous case. In A number we got the shunt resistance as 1.01 ohm, but here you look, the shunt resistance becomes 0.1 ohm. That means by changing the shunt, whose resistance is very low, he can change in the galvanometer, and which can measure 10 ampere current. Do you understand this math? Now, there is a difference between ammeter and galvanometer. This is the picture of ammeter and this is the picture of galvanometer. Ammeter is an instrument which is used for determining the magnitude of current present in the electrical circuit. That means the amount of current in the electrical circuit can be measured in the ammeter. And galvanometer is the instrument used for detecting the strength and direction of the small current present in the circuit. When there is existence of current in the circuit, that can be understood by the deflection of the galvanometer's pointer. Dear students, today I am to end up my class. There is a nice moral for you. Whatever you decide to do, make sure it makes you happy. Dear students, the virtual classroom cannot replace the traditional classroom, but you have to use this platform in this pandemic situation, and also you have to put your 100% effort to make you perfect for this class. Thanks for watching the class. Goodbye.